All right, guys, second half of section 6.5, apply systems of linear equations. So when applying systems of linear equations to problems, it's important to analyze each solution in the context of the situation. Like if you just get a number, your numbers for your answer, well, what does that mean in the context of the situation? And does your answer even make sense? That's a good thing to check. So, of the 17 species of penguins in the world, the largest species is the emperor penguin. One of the smallest is the Galapagos penguin. The total height of the two penguins is 169 centimeters. The emperor penguin is 22 centimeters more than twice the height of the Galapagos penguin. Find the height of each penguin. Okay, so got to think about this. The total height is 169. So if I add the emperor penguin, which I'm calling P, and the Galapagos penguin, which I'm calling G, if I add their two heights, if P and G represent the heights of those two respective penguins, should equal 169. Then next I can write the equation representing the height of the emperor penguin, because it says the emperor penguin is 22 centimeters more than twice the height of the Galapagos penguin. So the emperor penguin, P, is equals 22 centimeters more than, so I got to add 22 to twice the height of the Galapagos penguin, which is 2g. All right, so my two equations are P equals 22 plus 2g, and P minus 2g equals 22. No, that's not. I read that wrong. The first equation is P equals 22 plus 2g. If I subtract 2g from both sides, then I can set up the system to use elimination by subtraction. Okay, you could have just taken the equation for the emperor penguin and plugged it in and use substitution. In fact, the book is using elimination here, but it's not wrong to use substitution. In fact, I probably would have used substitution since the second equation is already solved for P. But let's see how they do it with subtraction. So I subtract these two, so P minus P would just be, cancel out. Now be careful, this is G minus a negative 2G, which is going to give you 3G. 169 minus 22 is 147. Divide both sides by 3, and I get G is 49. Okay, well, next substitute 49 for G in one of the equations. So I'm going to substitute it in the one that's already solved for P. That's 120. Now the solution would be G comma P. So 49 comma 120. Now those are just bald numbers, like they're just numbers. All right. But what does it mean in the context of the problem? That means that the emperor penguin is 120 centimeters and the height of the Galapagos penguin is 49 centimeters. Does that make sense in the problem? Well, yeah, it makes sense in the problem. Like you didn't get negative numbers, which negative numbers representing height just doesn't make sense. Okay, you can check to verify that. So if you add these two together, you should get 169, and you do. And if you take 22 more than twice the height of the Galapagos, so if I double 49 and add 22 to it, I should get 120, and I do. Alrighty, so here's one for you to try. Go ahead and pause the video. All right, we're back. So Jared has volunteered 50 hours and plans to volunteer 3 hours in each coming week. Clementine is a new volunteer who plans to volunteer 5 hours each week. So she's new, so she hasn't already volunteered at all because she's brand new. Write and solve a system of equations to find out how long it will be before they have volunteered the same amount of hours. Okay, notice Jared already started with 50 hours, but he's only doing 3 hours each week. Clementine doesn't have any starting off, but she's doing more hours per week, so eventually she's going to catch up to him. So Jared equals 50 plus 3 hours per week. Clementine is equal to 5x. 5 hours per week. Now, that might confuse you because both equations have w, but the other variable is different. Okay? Here's where the explanation for that comes in. You actually can use the same variables for both of these because it's talking about the number of weeks and the total amount of hours volunteering. So if I write the equations as, for Jared, his volunteer hours are equal to 50 plus 3 times the number of weeks. And for Clementine, her volunteer hours are just 5 times the number of weeks. Okay, so notice they're both solved for V, so I can substitute the 5W in for V in the other equation and get 5W equals 50 plus 3W, and then solve for W. Well, here I'd have to subtract 3W to the other side. And you get 2W equals 50. Divide both sides by 2, and you get W equals 25. Okay, now it doesn't ask how many hours they'll already have. Okay, you could get that by just substituting 25 in for W here. 5 times 25 is 125, so it'd be 125. So the solution would be 125, 25, which would mean that they would both have 125 hours of volunteering after 25 weeks. Okay, so the answer to the question is find out how long it will be before they have volunteered the same amount of hours. Well, it will be 25 weeks. All right, awesome. So that's it for this section. Please continue on to your assignments. And as always, reach out if you have any questions, and you take care.